Hello everyone, and welcome to Florida Math Exam, where we are doing another live session tonight. Tonight we are covering the material of this week's practice quiz. So we're going to go over the solutions of the practice quiz. We have in the description, we have the link to where you can go practice the quiz on your own. But this is the solution video. So we're going to wait for a minute for everyone to get on, make sure we have all of our broadcasts working okay. Of course, you can go to Florida Math Live to see what we're seeing here, what we're writing. And you can also submit your questions in the comments or where I'm putting this link here in the URL. We're going to wait for just one more minute for everyone to jump on. Post this in the comments here. Okay. All right. A few more seconds and we'll work our way through the solutions for this quiz. Okay, let's get underway. So we went into geometry this past week. Then we started on different types of transformations. So which of the following transformations is not rigid? Well, if you recall, a reflection, rotation, and a translation are all congruent. So reflection, it's going to flip it over, an axis of reflection. Rotation is going to rotate around a point. A rotation and translation, it just simply slides something over. So the only one that's different is a dilation. It will maintain the same shape, but it won't be rigid because it won't be the same size necessarily, right? So dilation, you could have something like this, and if it's kind of like the casting a shadow transformation, something like this, where it's going to be the same size, but it's going to be bigger. And this was a rough drawing, but it's kind of like, think about a light source casting a shadow is how dilation works. And that's the one that is different here, is a dilation, where it maintains the same shape, but not the same size. And so that would not be a rigid motion. Okay, so that's problem 1. Remember to post your questions if you have any. I can go into more detail about any of these particular examples. And at the end of the quiz, if you do have questions from summer school or anything like that, I can answer those as well. Okay, so which of the following transformations always results in an image that has the same size and orientation as the pre-image? So remember, orientation is, think of it maintaining the same cardinal directions. If it started pointing a certain direction, if it was an upright triangle or pointing north, and it were to move about, is it going to be in the same orientation? So a reflection might happen something like this. That'd be reflection, not the same orientation. Dilation, so which of the following always results in an image that has the same size and orientation? So it's almost easy to say, hey, maybe a dilation looks like it would have the same orientation, right? If we blew that up bigger, if we walked around A, B, C, messing with the colors now, sorry about that, A, B, C. So it's the same orientation, but not the same size. So dilation is no good here. A rotation might be something like this, if this is the original. And if we were to rotate around that point, there might be something like, I don't know, something like this. Like if the blue was the image from the pre-image that was rotated. Definitely not the same orientation, right? So rotation is no good here. How about translation? So translation, if we had A, B, C, where A is directly north of C and B is directly east of C. So this is simply just sliding something over, right? So it's going to be the same size. Well, bad example here. It's supposed to be the same size. A is directly north of C. B is directly east of B is east of C, just like in the pre-image. So translation is what we're looking for as far as the same size and orientation. All right, let's have a look at this image. So in the figure below, J is parallel to K, and both lines are cut by transversal T. So we have J and K are parallel, cut by the transversal T. And it's saying, suppose that T, if we moved it in such a way that angle 2 had a greater measure. So what would that really look like? That would be maybe something like this. Let's make a straight edge out of one of these. So if it were something like this, that if we, hopefully don't make this too messy here, but if T was rotated like this, such that, as you can see, angle 2 got bigger. Okay, so if that became bigger, which of the following here would be true? So how will the other angle measures change? Select each true statement. So the measure of angle 1 would stay the same. No, it looks like angle 1 would decrease in this scenario, so certainly wouldn't stay the same. Measure of angle 6 would increase. So this is the new angle 6. This is the old angle 6. We can see that it certainly did increase. So yeah, B could be one of our options. It's possible there's more than one correct answer choice. Let's work through these. The measure of angle 7 decreases. So angle 7 was this one on the bottom right corner of K and T. So maybe it'd actually help if try to do different colors here. So if that was 7, so this is the new angle 7 here. So what actually happened? So it was big, it was more than 90 degrees. Then when we moved it, it became just about 90 degrees in this quick instance. So it did decrease, right? It became smaller, angle 7. So that can be an option. How about D, the measure of 4? Measure of angle 4 would decrease. No, this is the old 4. This is the new 4. It got bigger, so 4 would increase. So I'm going to cross out 4. And how about angle 5? We're looking at answer choice B. So the measure of angle 5. So this to do in pencil. So this was angle 5 before, and now this is angle 5, right? The angle is formed here. So angle 5 went from something like this to something like this when forming that angle with K. So that's actually, it is in fact decreasing. So this has multiple choices, A, B, and E. All right, let us know if you have any questions that come up. I can go into more detail if need be. And all right, so Lewis set up an A-frame ladder so that the angles formed between each side of the ladder and the ground is 125, right? So we have these ladders that are leaned against each other, and the angle on this outside, right, is 125. And it wants us to figure out what is the measure of the angle at the top of the ladder. So this is what we're trying to figure out up here. That's what we're trying to figure out. How could we do that? Well, this is a straight line, so that's going to be 180 minus 125. Okay, so that should give us 55 inside here. This is also 180 minus 125, so 55. Okay, and now all of the angles of a triangle add up to 180 as well. So I'll do x for our unknown here, plus 55 plus 55 equals 180. All right, let's work that out. 180 minus 55 minus 55 more. So now the only thing that's left on the left side is going to be 70. Is that one of our choices, D? And there we have it. Pause right here on this solution for 1 second so you can pause the video if you need to later after the recording. Go ahead and post any questions you have right there in the comment box, or you can use that messenger link that I put in the comments. Okay, which of the following is a possible set of measures for the exterior angles of a triangle? So if we started with triangle, so remember the exterior angles would be if we were to extend these legs, these sides of the triangle like so. So that could be one exterior angle. This could be another exterior angle, and this could be another exterior angle here. And it's forming a straight line. So what we're actually looking for is the supplement. Okay, so what we're going to do is we're going to do 180, take away each of these. So I'll do the first one. So of course this is not drawn to scale. So if we had 60, 120, and 180. So this straight line, we would do 180, right, because it's a straight line. 180 take away 60, would give us 120 in here. 180 take away 120 would give us 60 in here. 180 take away 80 would give us a 0. We can't have a 0-degree angle. Okay, so I'm going to put the supplement of these inside or just above here. How about that? So the supplement of the 60 degree was 120. The supplement of the 120 was 60. And the supplement of 80 was 0. So these are the interior angles of the triangle. 120, 60, and 0. So in order for it to work, these three would have to add up to 180 degrees. Now, in this particular instance, it is true, but for a triangle, it has to be greater than 0 degrees. The angle has to be greater than 0 degrees. So this is not a possible solution. So now let's just find the supplements of the angles. Now that we've kind of seen the process that I'm looking for, so I'm going to do 180, take away 75, so you can kind of see the work I'm doing. And that gives us 105. I'll put that over the 75. Then I'm going to do 180, take away 85. Okay, that's the middle one, and that gave us 95 degrees. Now this is strange. So 180 take away 200. What does that give us? 180 take away 200. That gives us negative 20 degrees. Does that make sense? Can we have a negative angle? In some parts of math, you can have negative angles, certainly, but when measuring physical differences, you can't go down to 0 degrees and then keep folding in on itself. That wouldn't make sense. So B is not a valid choice. Let's try C. So for C, we'll do 180. Take away 80 is 100. Okay, 180. Take away 125. 55. 180 take away 155. 25 degrees. Okay, so all of those look legal. These are angles between 0 and 180 degrees. So all of these are legal. Now let's see if they all add up to 180. And if they add up to exactly 180, then we're in good shape. 100 plus 55 plus 25, doing it on the calculator so you can see what I'm up to. So I added these three together and I got 180 degrees exactly. So C is in fact a valid option. Now let's try D. Same process, 180. Take away 120. 60. 130. Oops, 180, take away 130. 50 degrees. And 180, take away 140. 40 degrees. So these are all legal measures in and of themselves of between 0 and 180, non-inclusive, of course. Let's see if they add up to 180. They have to add up to 180 exactly in order to be a valid triangle. And we got 150. So that does not equal 180. So D is not an option. So this was a good example because we had to know what the definition of an exterior angle was. Then we had to know that we needed to use the supplement, right, to find the interior angles. Then we needed to know that the interior angles had to add up to exactly 180. But not only that, we had to know that negative angles are no good for an interior angle. And we had to know that a valid measure for a single angle would be So valid angles would be between 0 and 180, non-inclusive. I'm sorry, shouldn't have done the equal to the opposite. Okay, so if it was a valid triangle could be 0.5 plus 0.5 plus 179. That would be okay, right? So it'd be an odd-shaped triangle. It'd be like almost a straight line. And these would be very sharp angles, something like that. But that would be legal as well. You cannot have negatives, so they have to be more than 0. So 0.1, for example, would be valid. And it has to be under 180. So that would be like an extreme range of still an okay triangle. Okay, thank you for stopping in, guys. Let me know if you have any questions on this material, other material we've covered this summer, or anything you might be covering in summer school. So go ahead and put those in the questions. If you have any, I'd be happy to help you with that. Also, remember to, if you want to see what we're actually working on, go to floridamathlive.com and you can see what we're writing. It's a nice interface where you can answer your questions. You can also submit questions through the link I put in the comments where it connects you to Messenger, and that will also help you be alerted when we go live next time. And we're aiming for 6:30 in the evening. We're finishing up the material that is pre-algebra, getting it ready for everyone to be well prepared to take algebra. The main classes I'll be doing in the evening. I'll be doing an algebra class and a geometry class every evening this fall. So definitely message me if you have an interest in that. Be happy to answer your questions on that. Okay, so let's work in this example. So Nicholas places his 30-foot step ladder against a house he is painting. If the foot of the ladder is 8 feet from the base of the house, how high above the ground is the top of the ladder touching the house, the nearest tenth of a foot? Okay, so let's think this through. So it helps to draw a building. So there's our building, and we have a ladder leaned up against it. So it's always a good idea to read through the question again and try to start drawing a picture. So we know that there's a building. We know that we're leaning a ladder up against this building, like so. So this would be like the ladder. Kind of show that we have the steps there. Okay, and so what are we trying to find? So we know that the ladder is 30-foot step ladder. So this distance, 30. We know that the distance from the base of the building is 8. And so we took care of you can almost start to like color code the paragraph, right? So we're painting a house. So we did that in the green. For the 30-foot step ladder, that's an orange. I like to do colors whenever I can to help connect the ideas. This says the ladder is 8 feet from the base of the house. I did that in blue. So how high above the ground are we? Running out of colors. Let's do the black pen. This fall I should get one of those packs of like 50 colors. That would be cool. Okay, so how high above the ground is the top of the ladder touching a house? So they want to know how high above the ground. Did I say above the ladder? How far above the ground is this point that the ladder is touching? So how do we find that out? Well, we know this is a right angle, and we have measures of 2 of our 3 sides of a triangle. We can use Pythagorean theorem. So we could do, let's write that down over here. And let's go ahead and stay with our colors here, right? So we want to know what this distance is. That's the unknown. And so one of our legs, I'll make that A. The longest side and the side across from the right angle is going to be the hypotenuse. And the other base, the base of this triangle, or the other leg of the triangle, is going to be, we'll do that so we have some room to write. That's going to be our other leg. Okay, so I'm going to start to replace these. So instead of a squared, I'm going to write x squared. Instead of b squared, I'm going to write 8 squared. And instead of c squared, I'm going to write 30 squared. Okay, so this is going to leave us with x squared plus 64 equals 900. Okay, and what we're going to do is we're going to subtract 64 from both sides. I'll leave the calculator open so you can see what I'm doing. Okay, 836. So we're left with x squared equals 836. Don't know if that's be a perfect square that we end up with, but if we take the square root of both sides, that's how we get rid of the squared term here. And this is going to give us x equals plus or minus. It's good to get in the habit of recognizing that when you take the square root, you do have a plus and a minus term, and that's going to be square root 836. Too fancy of a calculator for us today. Okay, so we want the decimal. And it did ask us to round to the nearest tenth. The 10th place is the one directly to right of the decimal here is a 9. And it's going to stay a 9 because we're not going to round down. We're going to leave that as it is. So that's going to be 28.9 plus or minus 28.9. When you take the square root of something, again, there's a plus or a minus because negative 28.9 times negative 28.9 gives us a positive 836 inside of a square root. So that's how that works. Now, as far as why is there not a plus or minus over here? Well, because after we find the mathematical solution, we have to think a little bit logically. I want to just be short and be thorough so we don't get sloppy, because the EOC exam at the end of the year is a graduation requirement. Throws curveballs like this at you where they may ask what is the negative solution of it. And if we don't practice showing that there's a plus and minus version, you may miss a awkward question like that on the EOC. Because we're talking about dimensions in the physical world, we don't really think that this would be a negative feet above the ground. That wouldn't make sense. So it's just the positive solution. 28.9. Do we have that over here? Yeah, right there. See. Yes, we do have that. Okay, thank you very much, everybody. Okay, just checking the question, see if there's any specific questions on this. Looks like I can go forward. I just want to leave this solution up for one more moment. And we'll go on. We're about halfway done with this quiz solution video. Okay. So we can be done with that. All right, next question. Question 7, almost done. So What is the height h of the isosceles trapezoid shown below? The height of h of the isosceles trapezoid shown below. Okay, we haven't covered isosceles trapezoids yet, but what it essentially means is this is a mirror image. So if we were to fold this piece of paper right in the middle, these 2 points would line up, right? These 2 points over here would line up if we folded this paper in half right in the middle. So what we're looking for is h. Now in the material we covered this week, this is all within the triangles. So we could work with a squared plus b squared equals c squared. And let's start to break this down. So let's look for triangle we could use. So this one looks as good as any. This triangle over here. Now we need to find two things here, right? So ultimately we want to find h, right? We want to find h, but we need to have two sides of a triangle in order to use the Pythagorean theorem to solve for the third side. So let me label this leg down here x. Now how could we possibly figure that out? Well, if this distance up here is 8, then this distance down here would be 8, right? And we know that because we have these right angles, okay? So those are all right angles. So that would make this base 8 as well. Now, we know a few things. We know that this over here would also be h by the properties of an isosceles trapezoid here. We also know that since we labeled this distance here x, that this distance here would also be x. And we know that this entire distance is 18. So 18 equals x plus 8. Okay, so now we're just going to go about solving for x. Subtract 8 on both sides. And you're adding like terms, so you have 1x, another x, that makes 2 x's. Now we're going to divide both sides by 2. So it's going to be 5 equals x. Okay? So if x is 5, then this is 5 here, right? From here to here. This distance here between here is also 5. And now we have enough information because now we have two sides of this orange triangle. Okay, so let's replace a with x, or found to be 5. The other leg is h, so I'm replacing b with h, and the hypotenuse is 13. Okay. Let's get the calculator out so you can follow the steps I'm doing here. So 5 squared is 25 plus h squared. That's going to stay h squared for now. 13 squared, as you can see, becomes 169. Now we want to subtract this 25 on both sides. So 169 minus 25 gives us 144. So h squared stays on the left side over there, equals 144. Of course, we want to take the square root of both sides because we want to know what h is, not what h squared is. And that's going to give us square root of 144, 12. And that's what we were looking for, right? So we had to do a little bit of a detour because we couldn't go straight to solving for h. We first had to figure out and use some of the knowledge we have about isosceles trapezoids to know that this small segment here was going to be 18 minus 8 divided by 2, right? So whatever's left over was divided between these two isosceles, these equivalent segments over here. And then we had to use this 5 that we found to plug that back into the Pythagorean theorem and solve ultimately for h, which is 12. And that h is also 12. All right. Good deal. Let us know if you have any questions. Thank you for joining, Dan and Lauren. Let us know if you have any questions about this material. Again, if you missed earlier, there's if you want to see what we're writing, you can go to floridamathlive.com, and there's like a nice interface with the video, and you can see what we're writing. This is kind of the behind the scenes camera. We're almost done with the quiz. This is the material that we covered this past week, and this is the solution video. So there's also a link in the comments to, I encourage you to try this quiz on your own, even before watching the whole video, just to see how you do. But this is a solution video for that quiz. If you have any questions, go ahead and post them here or at the floridamathlive.com. And there's also a link to receive alerts next time we go live, so you don't miss the next session. And again, it's going to be about 6:30 tomorrow evening that we're doing weekdays and Sunday night, especially those 5-6 days a week at 6:30. So let's go ahead and get on with this example. So what is the perimeter of a rhombus? A, B, C, D. Now, one of the properties of a rhombus is that each of these sides are going to be the same measure. Okay, so it's kind of like if you took a square and it maybe got wet in the rain, this box, and those sides are still straight, but it was made crooked. Okay, so we just need to figure out. So remember, the perimeter is going to be these sides added up. Since they're all the same, the formula would be P equals 4S. So as long as we find one of the sides, we can plug it into that formula if all of the sides are the same. But first we have to figure out what a side is. So what is that? We can't quite figure it out. We're not going right through segment lines, and since we're going at an angle, that's not really helping us. So what we do know is we know that the distance between here and here, right, that distance is going to be 1, 2, 3. So going back to same formula we're using all week, a squared plus b squared equals c squared. I'll replace the a with this leg. Okay, so if you can picture, what we're doing is we're just solving for this triangle here, and we want to find the hypotenuse of this triangle. So from here to here is what we're really looking for. So this side is 1, 2, 3. So replacing a with 3. I'll replace b with 1, 2, 3, 4, right? That's 4 blocks. So that green distance will be plus 4 squared, and that's going to equal, let's do blue. So this distance here, The hypotenuse is going to be our C, and we don't know what that is. That's what we're solving for. So I'll leave it as C, a variable that we need to solve for. So let's do the math now. So 3 squared is 9, plus 4 squared is 16, equals C squared. If we put those two numbers together, we'll have 25. 9 plus 16 makes 25. Take the square root of both sides to get rid of this squared. And that's going to be plus or minus 5. Remember, anytime we do the square root of something, it's plus or minus, even though we're dealing with a positive solution. In all of the examples today, you need to remember that when you do take the square root, there's mathematically a positive solution and a negative solution. EOC has all kinds of little questions like that to trip you up. But since we are in fact dealing with positive dimensions, it's only the positive solution that makes sense logically here. So if this is 5, we could do the math 3 more times, but if we remember the property of a rhombus, then we could save time, and we know that if each of these sides is equal, so we found one to be 5, each of those is 5, 5, 10, 15, 20. So our answer is going to be B. Okay. All right. Let's leave this solution up for one more second. Check our question page over here. All right. And we have about 2 questions after this. We are almost there. Almost done with the quiz 5, I believe it is. Solution video. All right. So which of the following points is located 10 units away from point 5, 2 on the coordinate plane? So 10 units away. So if we picture what's happening here, we have a coordinate plane, and I'll just plot approximately what the first scenario would look like. So if we have 0.52, that would be like over 5, 1, 2, 3, 4, 5, up 2, 1, 2, something like that. 0, 3, this orange point would be at 0, -3, so left and right, nothing, down 3. Yeah, let's just plot them all, give you an idea, just a picture of what we're doing. -5, -2, left 5, 1, 2, 3, 4, 5, down 2. I'm going to underline this one as blue. That's the main point that we're comparing all of these to. I'm also going to do the -5, 2 in green. Let's do -1, -6 in black ink. Left 1, down 6. 1, 2, 3, 4, 5, 6, something like that. And this last one we'll do in pencil. So left 3, up 10. So that would be 1, 2, 3, up 10. Maybe something like that. So we want to see which of these, so this distance, or this distance, or this distance, or this distance is 10, right? So how would we figure that out? Well, if you look at this, these are actually all a bunch of triangles. Okay, so this orange point could make a triangle with the blue point like so. The pencil one could make a triangle like so, right? And this would be the hypotenuse that we're looking for. There could be a green triangle that looks something like this. Not the most precise art, I just want to give you an idea of what's happening here. Then we have D, which is the one in is that the regular ink one? Well, anyway, there's another triangle that would look something like so. Okay, and we'd be looking at the hypotenuse for each of these. That's really the dimension that we're looking for, is that distance. Okay, now what's the best way to do this? So really what we want to do to see which one is 10 is, I'm going to try and do this as neat as possible, is I'm going to do the change in y's and the change in x. So let's do 5 minus 0. So that's the x portion of that distance. And remember, this is in absolute value. So if you do the absolute value of that, you're going to have 5. Now let's do the y. So that's going to be 2 minus negative 3. So 2 minus, that minus is part of the formula for finding distance. This 3 is, this negative is attached to the 3. So 2, take away negative 3, that's like 2 plus 3. That's going to be 5. Okay, then what we would do is we would take these two sides. So what we're saying is this distance on the orange triangle is 5, and the y distance, the y portion of that triangle is also 5. So we're going to put those into a Pythagorean theorem. So 5 squared plus 5 squared equals c squared, or 25 plus 25 equals c squared, or 50 equals c squared. If you take the square root of 50, you do not end up with 10, right? We want this to be 10. So really, when we get to the point when we're looking at what is c squared equal to, we're looking for 100, right? Because 10 squared equals 100. So that's a tip for what we're looking for. So A is not possible answer. So let's do the same process with the B, which is the green triangle we made. So same thing. So the x components, that's going to be 5 minus negative 5, absolute value of whatever that is. There's also 2 minus negative 2. So this is going to be 5 plus 5 is 10. This is going to be 2 plus 2 is 4. So if we put that into a Pythagorean theorem formula, so now what we're looking at is 100 plus 16 equals c squared. So the square root of 116, let me actually get a decimal number for you. So I'm going to go back to the orange just real quick and show you what the square root of 50 would be. So that would, c in this case would actually be 7.1, right? So that is not a solution. Let's do the square root of 100 plus 16. That gives us 10.8. We're closer, but not quite, right? Does 10.8 equal 10? Nope. So B is not an option. Okay, then we also have C. Which one did we do that in? That was in the black pen. So let's do 5 minus negative 1. So, right, 5 minus negative 1. Absolute value of that. And also 2 minus -6. So this is going to give us 6, right? 5 plus 1 is 6. 2 plus 6 is 8. This one feels promising. I have a good feeling about this one. Put these two numbers, right? Remember, these are the legs of, right? So this is 6, and this whole part here is 8. If we're going to find the distance here, the hypotenuse on that one. So we do 6 squared plus 8 squared equals c squared. I have a good feeling about this one. Okay, so if you put those together, we would have 100 equals c squared. Take the square root. 10 equals c. So 10 equals c, and the answer choice C happens to be the correct option here. I'm also going to, because sometimes there's more than one solution, I'm going to check D, and it looks like that was our pencil triangle up here, right? So we find, let's just check what the hypotenuse of that one would be, okay? And let us know if you have any questions, just put them in the comments there. If you are looking for what we're actually writing here, just go to FloridaMathLive.com, and there's a really cool interface for answering questions and asking questions and whatnot. Okay, so let's do the same process. I'm going to do 5 minus -3 in absolute values. We haven't, the absolute values haven't really done anything yet, but just for, let's not forget that that's going to be part of finding the distance. Okay, 2 minus 10. All right, we get to at least practice our absolute value skills. So 2 minus 10. Okay, so 5, and I'll make sure I'm extra clear on the step. So 5, take away -3. Because if we were to keep them inside of the absolute values, that would be the absolute value of 8. Remember, absolute value simply takes away the negative sign. So absolute value of 8 is 8. Now 2 minus 10 is -8. So after we take the absolute value of -8, we end up with +8, right? And again, these were the changes in the x's and changes in the y's. So if we put this into our Pythagorean theorem like we were doing a minute ago, 8 squared plus 8 squared equals c squared. That's going to be 64 plus 64 equals c squared. And we will be able to see that the square root of 128, the sum of a couple of 64s, decimal is 11.3 about. So C would be about 11.3 in that case, so not 10. So the only option here is C, okay? I'm going to leave this up for just a moment. See if we have any specific questions that came up over here. Go ahead and put any questions you have. You can message me through the Facebook Messenger so that you don't miss an episode. You can be reminded by clicking that bit.ly link, and that goes to just subscribe through Messenger. So a few minutes before we go live at 6:30 every day, it'll just be a quick reminder to jump on, get sharp, and prepare for our algebra and geometry lessons we're doing this fall. Okay. All right, so that was question 9. So we're down to the last one. So another geometry review. I promise this one will be quicker. All right, so the figure shows a quadrilateral, a four-sided shape is a quadrilateral, A, B, C, D, and it's reflected over the dashed line. Okay, so if we started with A, B, C, D, and we reflected it over this dashed line like so, we would have this image. This is the pre-image, this is the image on the right. And it's asking us to make that reflection over to create ABCD prime, and it's asking ultimately what is the measure of C prime. So they're asking, what is this in degrees? Okay, and we do know that by definition, when something goes through a reflection, it's not in the same orientation, right? It's flipped around a bit, but we can see that this, if you're to measure this, that distance, those two distances are the same. If you were to measure this distance, those two distances are the same. Those two distances are the same. Those two are the same. And every angle is, every corresponding angle is the same. So that's 55, because that's 55. B prime is 135, because angle B is 135. Angle D prime is 65, because angle D is 65. And ultimately, C prime is 105, because C is 105. Oops. Yep, C. Okay. All right, so we made it through the solutions for this quiz. I appreciate you for stopping by. If you have any questions, just put them in the comments there, or if you have any questions, if maybe you're working through a summer school class or anything like that, or if you have a question on anything we covered today or in the past couple of weeks, I can go over that if you post it in the comments. I encourage you to certainly click on the link in the description, and that will help you be alerted to when I go live next time. So it'll just send you a message a few minutes before we go live, so that way you're all caught up and not missing any of these episodes. And once again, if you want to see what we're writing, to see what's actually happening on the screen, I know you can't see this, there's a better interface if you go to floridamathlive.com. Okay, so I'm going to leave this solution up for just a minute, and I'll hang out if there are any questions. So I'll stay here for a minute or two to see what questions we have come up, okay? While you put any questions you have down, I'm just going to put each of these that we worked through today so that you can pause this video. Just one more opportunity to pause the video on the work that we worked on today. Of course, all these videos will be available to watch recorded after the live session. Okay. My assistant in the background trying to be helpful, I'm sure. Okay. So just giving one more shot for questions that come in. I know it's summertime, probably don't have a lot that you're working on unless you're in summer school, but certainly don't be shy. And if anything comes up, you can always message me ahead of time. Take a picture of your work problem that you're working on. Take a picture, message me, post it to the page, something like that, and I'll cover it in tomorrow's episode, kind of thing. All right. Hang out for one more minute. Okay, I think that about wraps it up, everyone. Thank you so much for joining. Remember to go to Florida Math Live to see exactly what we're writing. Okay, Florida Math Live. You can also click the link in the description to sign up for just get notifications. You can always unsubscribe, but get notifications about 15 minutes before we go live each day at 6:30. Maybe might push it back to 7 during the year. We'll see how everyone's schedule works. It's probably gonna be 6:30 or 7 for when the fall classes start. Also, go ahead and check the in the description. There's an opportunity to test yourself with this quiz. So if you're just catching the end of this, maybe before watching the recording, go ahead and test yourself with the practice quiz in the description. All right, one last opportunity for questions, and I'll sign off in about 60 seconds if we don't have any questions come in. All right, thank you very much, everyone, and have a good evening. I'll hang out for one more minute. Okay, we had one question I see about solving systems of equations. Let me go ahead and I know that's definitely a big topic on the EOC, and we spend a week or two on that topic in Algebra 1. Let me do just one systems of equations problem to get that question answered. Okay, let's do one of those. Okay, so systems of equations. We had a question come in about a summer school class. It sounds like someone is taking, so let me just answer this for you real quick. And if any other questions come in, I'd be happy to stay on and answer those for you. Yeah, let's do this one. So there's two ways to solve a systems of equations problem. And ultimately what we end up having is two lines, right? There's an equation for one line, an equation for the other line, and they can cross. Well, this is an infinitely many solutions problem. Let me do one, because that was a special case. Let me do, let's do number one here. So what I mentioned, why I changed problems is if you ultimately get something like 5 equals 5 after you solve for, if you're trying to solve for x and you get 5 equals 5, it makes sense. It's true, 5 does equal 5. But what that means is that it has everything in common, right? If you get, so that would be like a line that ultimately lies on top of the other line. If when you're trying to solve one of these and you get something like 2 equals 5, that doesn't make sense. That's not true. And that would be like two lines that run parallel and they never meet. They never have anything in common. Now the normal, unless maybe not normal, but the non-special case one is when there's one solution, and that's typically what we're looking for. We're looking for that one point in space and time where the two lines cross and they have exactly one point in common. So let's see if we can find the coordinate where these two lines meet. So let me do this. I'll copy them down, and I'll get the book out of the way so it's a little easier to write. Okay, so x minus 4y equals 8, and 3x plus 2y equals 10. So let's see if we can solve for this one. So there's two ways to solve for these. There's, well, you could graph it as well, but there's substitution and there's elimination are the two main algebraic ways to solve systems of equations. So we could do that. Let me do by elimination. If it was already solved for one of these letters, if it only had one letter on one side of the equal sign, I'd probably use substitution, where I would plug in everything on the other side of the equal sign into that variable in the other equation. But since these are nice and lined up, we have kind of an x column if you look at it, a y column, and then equals a number over here. So what we ultimately want to do is, if we were to add those columns together, we would want either the x's or the y's to cancel. And to cancel, they need to be equal and opposite. Okay, so equal in magnitude, but of an opposite sign. If I were to add these, I would have 4x, negative 2y, and 18. And that's not going to cancel. So we need to do something. So I can see that if I were to double the bottom line, right, multiply everything in this line by 2. Let's just see what would happen. So we'd have a 6x plus 4y equals 20. So I just doubled everything on that second equation. I'll rewrite the first equation. So that was x minus 4y equals 8. Okay. Now what if I were to add these vertically, right? So if I kind of just added those two equations vertically, so if we have a x and a 6x, that gives us 7x, a negative 4 plus 4, so those cancel, which is exactly what we were looking for. That's the entire reason I multiplied the second equation by 2, so that this 2 would become a 4, and a positive 4, when you add them, cancels with the negative 4. Over here, let's add those. 8, 20 makes 28. Now to get the x by itself, divide both sides by 7. So x equals 4. Now are we done? Not quite, right? So we need to find the y component of where this crosses. So where these two lines touch and what they have in common. So I can plug this 4 into either of these equations. The first one looks a little bit simpler, so let me plug it into that one. And what I'm going to do is I'm going to leave a space for where, I'll do it in different colors here. So I'm going to redo this first equation, equation 1. But instead of putting the x, I'm going to put a space to plug something in, right? Like so. I'm going to take this 4, because it used to be x in that spot, right? What do you think I'm going to plug in? Well, I'm going to plug in 4. Okay, now we want to get y all by itself. So the first thing we need to do is subtract this 4 on both sides so that it cancels. We'll be left with negative 4y equals 8 minus 4 is 4. Divide both sides by negative 4 so that cancels. So y equals, anything divided by itself is 1, but we're dividing by a negative, so that's going to be negative 1. Okay, so these two lines, if you were to graph them, they would cross, look something like this. They probably have different slopes, I'm sure, but they would cross at the point 4, negative 1. And that's systems of equations. So we solve for the x, and we solve for the y, and the 4, x equals 4, and y equals negative 1 is what these two lines have in common, is where they cross at this point. Okay, check one more time for questions, your last chance before tomorrow. And of course, remember to check out Florida Math Live to see the new clean interface where you can see what we're actually writing, okay? Okay, all right, everybody. Well, I think that just about does it. And thank you again for tuning in. Let us know if you have any questions. Feel free to message me, and feel free to click on that message subscriber link in the description, and that will help you make sure you don't miss any of the upcoming live sessions. Remember to bring your questions, post them in the comments if you do have any questions for me to cover next time. And thank you, everyone. Have a great evening.